So welcome to the second video on solving systems of equations graphically. So let's say we were given the following problem. We were told to solve um, y equals minus x plus 4 and 2x plus 2y equals to 0 graphically. Okay, so I'm going to use this grid below to draw these pictures, draw these two lines. So let's start with the first one. It is already in point slope form, and so it's easy to draw. Slope is -1 over 1, and the y-intercept is 0, 4. So I'll go starting at the origin, go to 0, 4, there's 1 point, and go down 1 over 1 because of the slope, and get that drawn. So super carefully, this is the trickiest part to do here. I probably didn't do a very good job of it, but that's all right. There it is. Let's check the next one. I'll do it in a different color. So this time I have 2x plus 2y equals to 0. So let's get this also into slope-intercept form. So we have 2y is equal to minus 2x. And I divide by 2. I get y equals to minus 1x. So that means the slope is minus 1. The y-intercept, this is interesting. So what we have here is 0, right? So the y-intercept is 0, 0. Right? So I'm going to start at 0, 0 and go down 1 over 1. So start at 0, 0, go down 1 over 1, over 1. All right. So I'm going to draw these two. Now, already you should have realized something. These two both have the same slope. So, same slope means parallel lines. That means they will never meet. What does that mean? Well, that means there is no solution. Remember what a solution is. A solution to a system is where they cross. So in this case, they never cross. So solve the system graphically, fine, you draw the picture. The answer to this question is this: no solution. Now be careful when you're doing these problems to always write no solution. This is also known as dependent. Oh, excuse me, inconsistent. Inconsistent. Right? This is also known as inconsistent. Inconsistent. So either of those is acceptable. You might see those words and those phrasings used in MyMATLAB. Let's take a look at another example. This time we want to solve the following system. Graphically. Right? So what is the system? X minus 1/2 y equals to 2, and the other one is y equals 2x minus 4. Okay, so again, let's get them into slope-intercept form. So the first equation, x minus 1/2 y equals to 2. Oh, I see a fraction, so I'm going to multiply by the LCD. Multiply by LCD. In this case, it's 2. So 2 times x minus 2 times 1 over 2. That's 2 over 1. Equals 2 times 2. So we have 2x, these cancel, minus y equals to 4. Let's solve for the y. So I'm going to minus a 2x, get minus y, minus 2x, plus 4. And that's a minus 1, so I can divide by a minus 1. And I get y equals 2x minus 4. That's the equation. Let's take a look at the second equation. I'll do that in red. So this is number 2. So this is 1, 2, y equals 2x minus 4. Hey, that's kind of interesting. And it's the same thing. Let's see what happens. So one nice thing is, of course, let's draw this. That should be easy to do because after all, it's the same line. So this first one, the slope is 2 over 1, and the y-intercept is 0, negative 4. So starting at the origin, 0, negative 4, right there. Slope is 2 over 1, so I'm going to rise up 2 over 1, rise up 2 over 1, rise up 2 over 1. And I can now connect these dots, hopefully, into a straight line. The more I have, the better it is, but again, no guarantees. There it is. And now the second line is the same thing. So if I were to draw that second line in red, it'll be right on top. So now the question is, where do they meet? Right? After all, the solution is where they meet. Where do they meet? And the answer is everywhere. Right? They meet everywhere. This situation is called dependent. So this is dependent. Right? It's not possible for us to give one dot and say, well, here's the solution, because every dot along that line meets. So there are many ways to write the answer to this. One way is to say dependent. Another way is to say the solution is the line itself, because that line shows you all the places where they meet. So I could have written this as y equals 2x minus 4, and that would be acceptable as well. Right? So two situations that you have to be aware of that could happen when you're solving systems of equations. One, they don't meet right there. That's inconsistent or no solution. And two, they're dependent, where they meet everywhere, called dependent, or you could give the equation of the line.